An exponential equation in which each side can be expressed in terms of the same base can be solved using the property if b to the x power equals b to the y power, then x equals y. In other words, if the bases are the same, set the exponents equal. So in our first example, the bases are the same. 7 to the 2x plus 1 power equals 7 to the 3x minus 2 power. All we have to do is eliminate the common bases, the same bases, and equate the exponents. And the rest is very simple algebra 1. Subtract 2x, add 2, and x equals 3. Don't forget to do the check step. 7 to the 2 times 3 plus 1. 2 times 3 plus 1 is 7, and 3 times 3 is 9 minus 2 is 7. So as you can see, 7 to the 7th power equals 7 to the 7th power, and the check step is good. Number 2, what do we do when the bases are not identical? Well, you try to make them the same. As you can see, 27 can be rewritten as 3 to the 3rd power. And since we have 3 to the 3rd power to the x power, we know that a power of a power must be multiplied. So that gives us 3 to the 2x minus 1 equals 3 to the 3x. Since we have the same bases, we can cancel out the bases and basically equate the exponents. 2x minus 1 equals 3x. Subtract 2x, and we get x equals negative 1. Check step results in 3 to the negative 3rd power equals 27 to the negative 1st power. Now, if you remember, your negative exponents means to reciprocate and then change the exponent to the positive. We end up with 1 over 27 equals 1 over 27. Now, if you're not so good at that, you can always just plug it in the calculator to show that we have a match. So this is similar. We have base 5 and base 25. Now, if we take 25 and rewrite it as 5 squared, then we can achieve our same bases. 2 times 2x is 4x, and 3x minus 8 stays the way it is. Cancel out the 5's, and now we have 3x minus 8 equals 4x. And the rest is simple algebra. X equals negative 8. Check step. 5 to the negative 32nd power equals 25 to the negative 16th power. And when I plug these into the calculator, I end up with, again, a match. Number 4. Now, what do we do if we have bases 4 and 8, and we can't really change the 8 to a base 4 because 4 squared is 16. What we can do is we can change both of them. We can revert both of these back to base 2. So we have 2 squared is 4, and we have 2 cubed is 8. So we end up with this right here. Don't forget, you must distribute the power to the binomial power, right? Because a monomial times a binomial must be distributed. Base 2's cancel out, and we're left with 4b minus 6 equals 3 minus 3b. The rest is pretty simple. 7b equals 9. Divide both sides by 7. And we have an improper fraction as our solution, which is no problem, 9/7. And what I'm going to do here is a little fancy, but I'm going to take 9/7, and I'm going to store it into the variable b, which you can access by hitting the alpha button. So now, every time I use the letter b, the variable b, it really means 9/7. So that means I can type in 4 to the 2b minus 3, I get this, and then 8 to the 1 minus b, I get this. It's a match. So I know I did it correctly. Okay, last example, number 5. Now this one, a lot of students freak out about this one because they see that this power has a power in it. It's not a big deal, right? Just stick with the program. Remember, we're just trying to match the bases up. So we have 4, we have 2. We know that 4 can be rewritten as 2 squared, and that's what we'll do. 2 squared, and 2 to the negative 6 power remains the way it is. So what we have to do is we have to distribute the 2 times the x squared plus the 4x. We can go ahead and get rid of the bases since they're identical. And we have 2x squared plus 8x equals negative 6, adding 6 to both sides. We have a quadratic to solve. It would make our lives easier if we divided everything by 2, giving us x squared plus 4x plus 3 equals 0. Factor and solve. Our solution set is negative 3, negative 1. For the check step, yes, you have to plug both of them back in individually. And as you can see, when we start with negative 3, we get 4 to the negative 3rd equals 2 to the negative 6, which does check out. Now let's plug in negative 1. We end up with the same thing. 4 to the negative 3rd equals 2 to the negative 6. So ladies and gentlemen, we have proven with the check step that our solutions are good, and that's the lesson. Good luck to you.